Hey guys, this is question MM037 of the Maths Methods Sharpen Study Guide. So the question asks us, consider the function f of x equals 2x times x take 3 and the function g where g of x equals x plus 4. And they've given a restricted domain on g from 5 on 4 to 4. If the function h equals f plus g, then the domain of the inverse function of h is. Okay. There's a few different parts to this question, and there are a few things that may confuse you or confuse a lot of students. So the first thing, we've got h equals f plus g. So firstly, we actually need to figure out what f plus g is. So we know that f of x equals 2x times x take 3, which equals 2x squared minus 6x. We also know that g of x is equal to x plus 4, and we're wanting to find h, which equals f plus g. So h of x equals f of x plus g of x, which equals 2x squared take 6x plus x plus 4, which gives us 2x squared minus 5x plus 4. Now I would actually draw this new graph, h of x, with your calculator, just to see how this domain has affected the graph. So because the domain of f is r and the domain of g is 5 on 4 to 4, what we actually need to do to find the domain of h, where h equals f plus g, is to find the intersection between these two domains. Now, because f has all real numbers as part of its domain, and g is 5 on 4 to 4, the domain of the new function is simply 5 on 4 to 4. So I would actually look at this domain in your calculator in the sketched graph, and from there you can actually see that the turning point of this graph occurs at x equals 5 on 4. If you want to do this by hand, you can see that the turning point of x equals negative b over 2a, where negative b equals 5 over 2 times 2, which is 4, which is the same x value as up here. So we know that the turning point is at 5 on 4, and we simply need to work out the domain of the inverse function of h now. Now the thing that people may get caught up with, and if you're watching this, you may have got caught up with this as well, is to actually work out the inverse function and then try and figure out the domain from there. However, the very properties of the inverse tells us that the domain of the inverse function h is actually equal to the range of the original function h, which I'm sure you've seen before. So rather than trying to figure out what the inverse function is, because it doesn't actually ask us what the equation of the inverse is, it asks us what the domain is. So if we can work out what the range of h of x is, then we can simply use that as the domain of the inverse of h. So how do we work out the range of h of x? So we know that the domain is 5 on 4 to 4, and we also know that the turning point occurs at 5 on 4. So at x equals 5 on 4, we're going to have the lowest y value possible, and at 4, we're going to have another y value, which is our highest y value possible within this domain. So all we need to do is h of 5 on 4, which equals 2 times 5 on 4 squared minus 5 times 5 on 4 plus 4, which equals 7 on 8, and h of 4, which equals 16. Which means that our range of h of x is equal to 7 on 8 to 16, and because our range of h of x is equal to our domain of the inverse of h of x, this is actually equal to our domain of inverse of h, which is answer A, 7 on 8 to 16.